Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan and I sit down with Julien, co-founder and CTO of Datakin. Julien has a long history of working with open source projects in data, from Marquez, Arrow, Parquet, and now OpenLineage. We talk about what it's like to create a standard, why data lineage is important and hard to collect, and why open source is essential to seeing that vision out. One of my favorite parts of this episode is when, Tristan, you compare how DBT thinks about creating standards to OpenLineage's approach. What stands out to you in this episode?
Well, it's funny you pointed that. I have such tremendous respect for Julien and the standards that he's been involved in creating, and I think that his approach of building consensus across like such a broad group of stakeholders is laudable, and I don't have the courage for it. We do take a very different, much more cynical approach, and we get into that in the episode. The thing that was most exciting to me about this episode is I love hearing stories about the creation of these technologies that we all have come to depend on. One of my favorite podcast episodes of all time is from the guy who created JavaScript, hearing about how he created JavaScript over the course of like 2 weeks or something very, very short. And hearing Julien talk about the creation of Arrow or Parquet. I mean, these are things that I've been learning about and using for such a long time now. So it was a real pleasure to hear the story from his mouth.
He makes it look easy in creating standards, which are, they're not. So I really love that part of this episode, and especially just all the open source mentality. It's been fun seeing what he's done over the years and how we also can partner with him. So without further ado, let's get into it.
Julien, it's so great to have you on the podcast. I want to go back into history. Julia's going to have a lot of questions for you on what you're up to right now, and we'll get into that a little bit later. But I want to dive through history a little bit first. You started your career, I think, in France. Is that right?
Yes, that's correct. So I was, I did my master's degree, and I started working in France. And the company I was working for, which was a shopping comparison engine in Europe, got acquired by Yahoo, which kind of started my interest in data.
I saw that in your bio, and I imagined that that's how you made the leap across the Atlantic. Did they ask everybody to move, or did you raise your hand and say like, hey, I've always wanted to go to Silicon Valley?
So it was more that one, yeah. So they did it. No, the company kept growing. I mean, there's like a long story there, and Yahoo had interesting evolution since then. But no, at that point, I was actually interested in moving to Silicon Valley. As being a software engineer, it's kind of a place of opportunities, and working for an American company made it a lot easier, right? Because you can just transfer internally, and it's a lot easier than just applying remotely for a job. So I did that, and then I joined a team that was building a common backends for all the listing or feed-based media properties of Yahoo. So you can think Yahoo News, Yahoo Movies, Yahoo Autos, Yahoo Shopping. We do a lot of ingestions of various feeds, and then they do like categorization, matching, entity extraction, like a lot of organization. And so we were building a common backend for all of that on top of Hadoop, since Yahoo were the place where we invested a lot in Hadoop and got it big at the beginning.
I thought that was going to be where your Hadoop journey started. I'm a person who was involved in enterprise data at that time, but was not involved in the Hadoop stack. I was like more in the Oracle, Microsoft world. Mm-hmm. And now, coming to the modern data stack a little bit later, I am exposed to stories about that era of Hadoop, but I never got to experience it myself. So it sounds so. What were there, 100 people involved in Hadoop at that point in time, and you all like met up at the local bar? Like, what was the community like?
It's funny. So I was involved. I was not working directly on Hadoop, but I was on the team, like very close team that was working on building platforms on top of it, right? Like, so Hadoop started from the search organization and started being used in other organizations, and so that was interesting. Like, I remember there was like a coffee bar in the building, and the Hadoop team was in the same building. It's probably like fewer than that at the time. And there was one of the team members had a T-shirt on the back that said, "Scaling Hadoop to 20 nodes," like it's a big arrow going up and to the right. And I remember that it was like, wow, those were the days. So of course, now people have thousands, if not like orders of magnitudes, over thousands of nodes in their clusters, and it's kind of the stack kind of evolved differently. But that was the time. So yeah, I remember there was a Hadoop meetup, which would be every month in the cafeteria on the ground floor of the building where I was working. So it was kind of a small-ish community at the time.
The Hadoop story since then has obviously, and I don't have to, it goes without saying, there's a tremendous amount of creativity and amazing value for the world that's been created in that ecosystem. If you want to focus on the commercial side of the story, it's been a little bit more mixed. I'm curious if there are things about the commercial part of the way things developed that you think the ecosystem got wrong, and do you think that there's any chance that we're doing any of that stuff better in the modern data stack today?
Yeah, that's very interesting. So we talk about Hadoop, and then we talk more about the Hadoop ecosystem, right? Like all the things that were built around it. And I think over the years, there's been more and more of the Hadoop ecosystem growing and more people using it. And at some point, like people not really using Hadoop anymore. But still, like a lot of things that happen in that ecosystem were used. And some of it is, so focusing on the first part of your question to start with, I think there's been a lot of evolution with cloud as well. Like Hadoop was very much like an on-premise, you manage your own storage and your own processing, and it evolved very much toward the cloud over the past more than 10 years. And Hadoop has two things, right? It has a distributed file system, and then it's like the distributed computation engine on top of it. And the storage layer moved more and more into cloud storage solution like S3 or, the equivalent in other cloud providers. And then the processing got like kind of more separated, and it's kind of like Spark took that niche in a kind of better MapReduce, more expressive way. And it's kind of like, and it's interesting how Spark is moving towards SQL, like and looking more and more like a warehouse. And on the other end, if we look at the modern data stack that's focusing a lot on SQL as well, you have those cloud data warehouses that started like evolving, like, starting from back in the day, we were using Vertica, or you're thinking of like Oracle, like those very like on-premise kind of heavy handed and hardware plus software solutions. And then you move to the cloud, right? If you think of Snowflake and BigQuery are like really cloud native data warehousing solution, which kind of are part of the same similar evolution. Like, so Hadoop was at the beginning is like, databases are kind of like very constrained and they don't scale that much. Like if you think of the regular OLTP kind of database. So let's restart from scratch, right? And we do MapReduce, and it's lower level, but we can do whatever we want. And it's kind of slowly evolved back to SQL. And at the same time, the SQL databases evolved to distributed systems that look kind of, if you look at the way Snowflake or BigQuery work, was kind of separation of storage and compute. And they look a little bit more like Hadoop. So there's kind of a bit of convergence and evolution toward the cloud. And I think some of the issues with the model of commercial Hadoop was like, it's a pain to run yourself, so we're going to help you run it yourself. But I think the real solution is, the people don't actually want to run it. They'd rather use cloud solution and it's run for them and they can focus on solving their issues. Yeah. Right? It's kind of my vision of that.
Maybe it honestly doesn't have as much to do with Hadoop versus modern data stack, and more it's about these types of distributed systems require the cloud, regardless of like what the technology lineage is of the set of products you're using. It is just a good time to be building cloud native solutions today.
Yes, I agree.
Last thing before we can get into some of the stuff you're working on now. I took a look at the list of Apache projects that you've been involved in, and it is a long list. So just for the audience, the list includes, and you tell me if there's stuff that I'm missing here, but Arrow, Kudu, Parquet, Pig, Tez. Anything I'm missing?
Iceberg.
Oh, really? I didn't know that. There was exciting news coming out of there recently.
Yes. I mean, to be fair, I've been involved at various levels in some of those things. So there are some projects, like obviously Parquet, I was one of the co-founder and driving the project for a long time. Arrow, I contributed to really getting that project started as its own project. And some other, I've been kind of helping people going through the incubation stage, because once you got through that process, you can get along. And Iceberg, for example, is really Ryan Blue's project, right? And Ryan Blue has been a long time contributor and one of the pillars of the Parquet project. And really, Iceberg came from him, and I barely kind of been cheering along and helping a little bit on that.
I've heard the Parquet story before, but just like a super abbreviated version. I'd be curious to get you to tell just a little bit of it now. It seems like a super cool origin story.
Yeah, that's interesting. I think, and I learned a lot from that. So, I was at Yahoo, I started contributing to open source project like Pig, for example, at the time. And Pig was like before Spark, the better MapReduce. And that's how I joined like this larger open source community and I got my first Apache committership in the Apache Pig project, which was interesting. And so that's how I joined Twitter afterwards, right? Like the big community around that project was Twitter, LinkedIn, Netflix. And it's kind of like there was a strong community around that. That's how I joined Twitter. And at Twitter, we had Hadoop and we had Vertica. And Vertica, so it's the distributed columnar data warehouse, and it's much lower latency. You have SQL. It's optimized for getting lower latency response to your big queries scanning a lot of data. But at least at the time, it didn't scale as well as Hadoop, right? So it has like a fraction of the data. It would not have all the tables. It would have less history of data in each of them. So that was limited. And like Hadoop would scale better. You would put all the data in it. I mean, all the data we kept. But of course, Hadoop is like these heavy-handed, high latency answers. It's better for throughput and doing a lot of processing in the background, not really for getting quick answers. So that's really what it started of thinking, how can we make Hadoop more like Vertica, right? Like it's kind of like, and so I started looking into, I had already read the Dremel paper at the time. And so the Dremel paper, you have two main contributions, right? There's like the distributed query engine processing, and then there's a storage format, which is described in there. And so I started implementing the algorithm that described in the Dremel paper just as a side project. At the time, I was commuting on the shuttle between the South Bay and San Francisco to go to work. And so I had like 45 minutes every morning, every evening, and I don't get sick in transportation. So I was on my laptop doing my side project and doing that. And when it started getting like more like concrete and it started working, and I was like, okay, if I'm doing this, if I'm trying to convince management we should do this, this can't be something we do internally as a proprietary solution, right? Because then you need to integrate into everything for this to be useful. So I really started trying to reach out in the community and find other people who would be interested. And that's how I connected with the Impala team at Cloudera. And they were actually prototyping a columnar format around the same time for Impala. And they were like, okay, because they were trying to do the same thing. And so we joined forces and we merged design. It was great because from my end, I was starting from the bottom, like integrating with Pig, with all the Hadoop stack and making it work there. And that brought all the requirement of a query execution engine like Impala and making it really performance and validating the design that it would not impede performance from this side. And on the other side, they were doing kind of native code execution for Impala, like C++ based or LLVM code generation. And so having all the integration with the JVM based Hadoop world was a great collaboration. So it's been a very, very good and productive collaboration pushing that project together. Yeah, and then so we started with just the two entities, and then Netflix started being interested, and they started using Parquet and contributing to it. And there's Criteo, which is a company in France who does ad targeting, started contributing as well. And then Spark SQL happened, and decided to use Parquet at the backend because for same reason, right? They wanted to build like a faster query engine. Then it took a life of its own, right? It's kind of from that point you get critical mass.
It seems like it's kind of the default high performance open source file format, at least today.
Yes, well, I'm not going to say the opposite. Yes, I agree. And to the point that like BigQuery, Snowflake, Redshift, they can all read and write Parquet now, right? Because they need to interact. You need to connect your warehouse with your data lake if you have both. So it's been, and I think I've even one interesting anecdote is as part of being on the Parquet PMC, we got contacted by Microsoft to ask for permission to use the Parquet logo in Excel menu. Because, so you're mainstream when Excel supports your file format.
Nice. High performance Excel reads and writes.
So you can import from Parquet, imagine, or something like that. So yeah, like if Excel is not the most used data tool, I don't know what is.
You've triggered so many thoughts in just that few sentences. The first is, I wonder how many side projects that are not happening now because people aren't commuting from San Francisco to South Park on the Caltrain. What could have been if you didn't have a really long, monotonous commute? But I want to kind of switch gears a little bit. So Tristan's right, you've been involved in so many open source projects, and they're very, very different, many of them. But one of the themes that we keep seeing in projects that you've worked on with Parquet and Arrow and now OpenLineage is this idea of needing open source to deliver a new format or framework. I think there's a really interesting trend happening in both open source communities and open source or open core companies where standards are being delivered through open source. Why is it that you think open source is the right way to get these to market? And what are some of the challenges maybe in the open source route?
Those type of projects really benefit from being open source, right? So they kind of arise from a common need in the data community for at large for shared understanding, right? So it's kind of, if you take Parquet, there was like, whether it was Hive and Spark and Impala and all of those things, right? People use different tools and they need to be able to be interoperable. And that creates kind of a need for, that makes it needs to be open source, right? It needs to be shared. It needs to be something that's going to be able to integrate in the whole stack. And that creates, so the good thing about open source in that context, it creates really healthy incentives. And like you get started, right? And at the beginning, there's like one or two things using it. And then you grow a little bit. But the more project integrate with it, or the more people use it, the more it becomes valuable for everyone, right? Because so there's kind of every one little person joining or like integration adding to the stack, it makes it more valuable for everyone. And so there's really kind of this flywheel mechanism and like being part of the community, and then you reach critical mass and there's an inflection point, and then the project takes off, right? Because then it makes no sense to do something else, right? So this is really, it's kind of, those mechanisms are really important. So like Apache Parquet was like that. It's kind of the first, so it's kind of figuring that out along the way. And then Apache Arrow, really we realized in the Parquet community, well, there's a need for similar columnar in-memory representation for sharing data at runtime between query engines and processors. And it has different constraints, so it needs to be fundamentally different from Parquet. And so we really leverage that existing community and like, okay, we need to bootstrap the same mechanisms, right? There needs to be a lot of people involved. We start like agree on the fundamentals, and then we start building more adoption around that and create around this original core. And then, it kind of takes off. And nowadays, for example, Apache Arrow is the same, right? You can retrieve your result set from BigQuery in Apache Arrow format, just because it's going to go much faster. If you have Python and you're reading from BigQuery, then it's going to be much faster processing in memory. You avoid all the conversion and all of that. And so an OpenLineage is really similar in that sense. So in that sense, it's not like query processing optimization, but you have the same need for everybody to understand lineage in the same way and to be able to exchange lineage information so that data catalogs or data quality, data observability, query engines, schedulers, they can all connect together and we can build that map or how everything's connected together. And so it really benefits from starting in the open source, starting with building consensus around core capability in this ecosystem and reaching out to people in other open source projects or in proprietary software and kind of agreeing on a base and then building around it and really building both the various features around the core standard, but also the community and the adoption. And really, there's this need exists, right? So all we need is kind of create this focal point that's going to get people's attention and say like, oh yes, we need to contribute to one thing. And so this is the thing. And so let's make it happen, right? So it's kind of this whole thing.
Like the network effect. I think it's interesting. One of the trends I've been noticing is like the first wave of infrastructure, open source companies were really infrastructure companies, Mongo, Elastic, Confluent. And we seem to see a larger number of these like frameworks or standards, open source companies that are coming up today. And, DBT is certainly one of them, Anyscale, OpenLineage with Datakin. And it's interesting way you have to build the open source project and community with how do you become that standard? Like that's a very hard thing to do. Of course, open source is a great way to get everybody on board. You don't have lock-in into a company. You have governed by the community in many ways. But then you have to build product around how do you make it really usable and how do you scale it? And that's where some of the business side of the open source projects come in. I'd love to go a little bit deeper into Datakin. So you gave kind of a preview of what you're trying to solve, this open format for metadata. At what point do you think that this is useful for companies? Is it all companies have this challenge? You've spoken about in the past, we have this concept of data mesh. We've talked about it on the show before, where different teams own their own mini data stacks, and it becomes really hard at the intersection of all of those. And so if you have this open standard around metadata that you can share across teams, well, then you're golden. But do all teams have this need, or is there some point at which this becomes important?
Yeah, so the one thing that's interesting about data lineage is like, depending on who you ask, they have a very different definition of what data lineage is. And the reason is like there are many different use cases, right, for this. And some of the use cases, there's like data quality, reliability of delivery. There's kind of like compliance and with like GDPR, CCPA, SOX, or other banking things. And there's governance, making sure that your metrics are actually derived from the right source data set. And so all of that becomes hard to ensure and make work when you start reaching a certain level of complexity. And so and that level of complexity, and typically it's like there's more than one team involved in data, right? Like as long as you have one team who's responsible end to end, like from ingestion, ETL, transformation, like exposing the data kind of end to end, it's really clear. Like people can communicate, they know how everything works, they can figuring out where their definition, and it's fine. When the complexity starts growing a little bit and you have more than one team doing data, you start having frictions at the boundary of the teams, right? And that's where teams might have like slightly different practices or convention and things are less obvious, right? And then they know the data they're consuming, but they don't know necessarily what's upstream of it or where it's coming from. And they know the data they're producing, but they're not necessarily aware of all the things that depends on the data they're producing. And they may not have signed up for supporting a specific, like really difficult use case. And now they're on the hook for making that data reliable for this specific use case downstream. So there's kind of a lot of that. So typically, either number of teams is one context where you start really, data lineage is this way of building the map, right? And you have an automated way of having a map of the territory and understanding who you depend on, who depends on you, all of those things are depending on together, whether it's of use or not. And other aspect is people using different stacks, right? So you may have analysts who use more SQL. You may have machine learning engineers who use more like whatever training model. You may have people working on the ETL stack and getting data from various locations. And so often the complexity also comes from using different stacks. And because then they use different toolings. Analyst people will know how to look at SQL to understand their dependency, or DBT, right? DBT is great as showing your lineage within your project, but then they will be lost on, but actually this data is also used to train some other model, and that goes into the product. And when that breaks, the company loses money or something. So there's lots of levels of complexity, and sometimes it's also just not organizational, but it's just over time people have used different technology. Maybe they started with Hadoop and they have like 5 MapReduce jobs that are still running on a cron job that nobody's touching, and maybe at some point they move to Spark, right? And then there are a bunch of Spark SQL jobs, same thing, that's running, and then they started using DBT against Snowflake, and those things accumulate, right? And they use kind of different eras of technology, and maybe it's too expensive to just rewrite everything to DBT and say, oh, now we have the nice environment when we understand everything. So there's kind of different aspects like that introduce complexity and make it hard to understand what's going on, or make it hard to troubleshoot problems. And it becomes like a real, and it's in fast moving environments, where a lot of things are changing. If they're building analytics for their product, the product is changing constantly. The way metrics are collected is changing constantly. So there's lots of room for breaking things without really understanding, the impact. And so that's where Lineage is really important, either for, reliability of data, or ensuring compliance with regulation, or ensuring that actually this metric we're making business decision from is actually derived from the correct data source.
Yeah. So people talk about Lineage a lot. I think people agree it's useful in this abstract word lineage. We need to have metadata about our data, but then it also introduces this other challenge where we just have more data to see, right? What tangibly can you help people solve, and how do you give them the right insight to fix the problem versus more information overload?
And I assume that Datakin is actually going to target one of the Lineage use cases first. Is that right?
Yeah, that's correct. So, as I'm wearing 2 hats, right? Like as the OpenLineage hat, I kind of like enable the ecosystem, right? And there are a bunch of use cases. We talked about governance, compliance, operations. As my Datakin hat, I'm focusing specifically on one, on kind of data reliability, right? So it's kind of, and this is one thing also, you talked about the first generation of open source. This is where, Datakin is not hosted Marquez or OpenLineage, right? It's its own product. And OpenLineage is our way to make the whole industry much more transparent about what Lineage is, right? And then OpenLineage is really focusing on the fact that the best time to collect the lineage is at runtime. When things are running, that's where like you can collect all the metadata you want, instead of going, to the side, to whatever logging is already existing. It's like that's very lossy and lost a lot of information. So if you look at concretely the problem we're solving, Datakin specifically, we're looking at making sure the data is delivered on time, and it's correct, right? So it's kind of this whole data quality, freshness, running on time, and really being able to quickly figure out the root cause of a problem. When you have a data quality issue, it always comes from somewhere upstream, right? It's kind of like very rarely is just, oh, your query is wrong. Well, no, something else upstream has changed, and maybe it's the way we instrument. Maybe it's a third-party data you're receiving, or maybe someone changed the logic somewhere of some transformation. And so it's really about really quickly finding the root cause of a problem. Like today, people can take weeks. It's hours, days, weeks to figure out what the root cause of the problem, because you see what your data looks now. You don't know what it looked like yesterday. And figuring those root cause quickly, doing impact analysis, like understanding if you're going to break something, because often people end up not touching anything or duplicating pipelines, because when they change something, they break something. And not only they break something, but they don't know they break something. And it's going to come back to them, at the end of the month where we can't close billing anymore, or things like that. And so it's really what Datakin focuses on. Now, the other use cases, there are a lot of people using OpenLineage and Marquez, for example, for privacy. I want to know that my user private data is going where it's supposed to be going and not somewhere else, right? Like we are using user private data in the way that consent was given by the user, like to enforce GDPR, CCPA. So there's a lot of activity in that space that OpenLineage enabled because it keeps track of exactly how data has been transferred. And of course, there's more like general usage of Lineage, which is more like general understanding. I want just to understand how things depend on each other, right? It's like inspect and build a map of all the data transformation. Is that what you had
Yeah,
in
no,
mind, Julia?
that totally makes sense. It's in the interoperability between different investments you've made in your stack where things get hard, knowing what might have happened upstream or downstream. And that's where Lineage can actually be really illuminating for people. So I'm curious, it is hard because you have to work with a lot of different parts of the stack. And that's why the standard's so important, right? You know, eventually you'll go from being able to integrate with everyone versus you'll just be the de facto choice and people will have to start integrating with you, or OpenLineage as the format. How do you go about and actually becoming a standard? And maybe Tristan, I'll ask this of you after too, since we're doing something similar with DBT, but it's a hard thing to become the accepted choice for X. What are some of the playbooks that you're using to get there?
Julien, can I say first, I think we're taking different approaches here.
I was going to say the same thing.
Okay.
I think what works for DBT is very different from what works for OpenLineage. They're very different. Yes, I agree.
So my guess is that this, to a certain extent, comes from our worldviews. I'm a very skeptical person, and I never in a million years would ever think that I could go out to a bunch of technology companies and convince them to integrate with DBT, and that would be awesome. And so we built DBT in a way that didn't require permission from anybody. It seems like you're taking kind of the opposite approach, which maybe it seems like you've seen this play out before you were telling the story of Parquet before. You've seen standards become established and that it actually works. Maybe you're not as skeptical of a human as I am, but does that mean that you then have to actually send an email to Frank Slootman and say hey, I think Snowflake could really speak OpenLineage, so we don't have to go out and get your query logs?
That's exactly what I do, and not to the CEO. So I didn't email the CEO directly, but you just
Frank, if you're listening.
I did not. The idea of I didn't specifically email the CEO, but the general idea is that, and I'm leveraging the network built around all those open source projects over the past 15 years, right? So it's kind of is this relationship that exists, and we've been collaborating and with different people along the way, it's kind of part of it is that, and it's not. I think DBT is becoming a standard because of the great user experience, right? As an analyst, you get an awesome experience. It's so easy to test locally, make sure everything is working before you push to production. I don't want to play the comparison game, but which other existing experience don't allow, right? So you have really this great experience, and I think DBT is becoming a standard because it's winning the hearts of all the practitioners, and this kind of this is such a better way to working together. Where Parquet and OpenLineage and all of that, if I do my job correctly, users don't have to know about it anymore, right? It's kind of more a back-end blobbing aspect. And so the way this built, so it may look and I got this feedback before, it's but it's going to be designed by committee, it's just going to get forever, you're never going to get there, you need to convince everyone. Well, no, I don't need to convince everyone. So first, I started from reaching out in the community, right? So I reach out to Tristan, I reach out to a bunch of people in this world, and we're okay, there's a need for common lineage across everything. First, do you agree? Is this something we agree on? And so what we want to do, so, obviously we had Marquez, which Marquez is this collection of lineage, storage, versioning is kind of very focused around the more operational aspect. And we're thinking, well, I see all those open source projects, whether it's Data Hub or Amundsen or and so on the data catalog metadata side, and then you have all the Spark and DBT and all the SQL and Pandas and all those things. And do we agree that we need this common way of representing lineage, and it would be much more valuable for everyone if I build that picture of all the data, like metadata consumers, all the metadata producer, and it's a big mess of like everybody's talking to everyone. Instead of everyone trying to figure out point to point how we do this, we kind of work together and we kind of standardize a little bit more. And instead of having n square connection, right? Like you have this central point and like it's two ends. Sorry, talking in a mathematical number of edges in that graph. It's a graph. Instead of connecting all the nodes, you put one node in the middle and everybody goes through it. And 90% of people were like, yes, we need this, right? But they kind of, why doesn't it exist already? Well, it's not going to exist until someone plants the seed and we start building around it, right? And the idea is we don't need agreement of permission of everyone to build it, but we need sufficient buy-in of people who say, yes, if it exists, I'll use it. And then you have a smaller number of people, not only would I use it, but I'm willing to contribute. And then you have a smaller number of people who are just like, oh yes, we're going to keep pushing that thing. And then once you have this core and you start like slowly building around it, then it starts happening, right? Because all people need is the thing to exist, right? To start using it. And so it's just like, and I think it's all about putting the right incentives in. It's like, so we put the project in the LFAI and data, which is a foundation as part of the Linux Foundation, right? It's really about, we're building this together, right? It's not going to be my project. It's going, and it's very specific to this type of project. I'm not saying, there's a foundation aspect because, for example, dbt does not follow this concept and it's fine. But for something like Parquet or like OpenLineage, which is kind of more the back-end side of thing, it is kind of really important that, look, this is going to be Switzerland, right? And it's kind of going to be a neutral thing and everybody has the same influence in it. And the way open source works is like whoever is pushing harder to make it happen ends up having more influence in it, right? So there are also incentive to contribute and be part of the community and be part of shaping how this works, right? Because it's going to work better for your stack.
Hey everyone, just dropping in to let you know that the annual Analytics Engineering Conference, Coalesce, is back. We had the first Coalesce last year in December, and it was fantastic. We had 3,000 registrants, tons of presentations, and this year is going to be even bigger. Register for free at coalesce.getdbt.com. Okay, I'm going to ask something that is maybe incredibly basic, but I want to ask it anyway. If OpenLineage is a standard, is the thing that is open sourced code, or is it a spec? What is the actual thing that you're applying the Apache 2 license to?
So it's both. And, here I'm really abusing the word standard because it's kind of like, when people hear about standard, they expect there's a committee, right? And it's kind of like there's a group of people who get together and they agree and they build, and there's one thing and it's released and then it's fixed in time, right? So what's interesting about things like Parquet, Arrow, or OpenLineage is kind of like this very open source way of building a de facto standard, which is about we are not going to wait until we know exactly all the people that should be involved and get them as involved, each of them equally, and like having this heavy-handed process, right? So to get to your question, right, it's a spec. So there's a spec and there's like some markdown files that describe how it works. There's some JSON schema, and actually it's interesting, like dbt uses JSON schema as well for its metadata. So JSON schema is a very interesting project that defines schemas for JSON, so it really formalizes what the metadata looks like. And it's also code with a bunch of integrations to start collecting lineage in the format defined by that spec. And this is really about bootstrapping the ecosystem, because eventually it's kind of the best solution is each project is kind of, they produce OpenLineage natively, right? And that's what proprietary system will be as well. Like they expose their lineage in OpenLineage. So really people would depend on the spec itself, and the spec in itself is the most important part. But to bootstrap this, we have clients in Java and Python, to make it easier for people to make their integration. And we also have integration with Airflow, BigQuery, Snowflake, Redshift, Spark, dbt, all the cool kids, great expectation on the data quality side of things to really start like making it happen, right? Like you already in the whole ecosystem, you already have all those things. And of course you can use Marquez to consume the lineage and explore it. You can use Datakin, and the Edge Area project is also using it. And as part of the, talking about building a standard, the initial spec on purpose, it's really focusing what's the minimal thing we can define about lineage. And it's really about, there's a job that's running and that's reading from datasets and writing to dataset. So a job could be a SQL query, right? That's reading from a table and writing to tables. And then everything around it, we have this notion of facet. And a facet is its own tiny spec, and it's defined by the JSON schema as well, that focuses on one aspect of the metadata. So for example, the schema of the table, or the data quality metrics, or what was the version of the code as of like a Git SHA, for example. And each of those things is its own facet. And what that enables is having a bunch of focused conversations, right? Instead of having one gigantic spec where we have to take years to reach consensus, we have a bunch of tiny spec that can evolve independently, that can have different people driving it, right? Obviously, data quality metrics. People who work in the data quality space have an interest into chiming in and like giving their version of it and helping shape that so that it works well with their solutions. And that's why we have a great expectation, define one. But at the same time, so that's kind of different from their traditional standard definition, right? Like, and then it becomes a standard, but it's really breaking it up in a bunch of tiny things in what makes it like move really, and it's kind of enabling like LC, avoiding stalling in the conversation, right? It's just like, no, we'll have only the people who care about that particular aspect, and they're going to discuss only that particular aspect and get to a conclusion, and then we move on, right? And then various aspects can move faster than others. If something is not easy to get an agreement on, it's going to move slower, but it's not going to block other things that are more straightforward.
Got it. I just want to like pull apart a few things here. So you have the OpenLineage, which is the formats for metadata. Then you have Marquez, which is a reference architecture that can consume the metadata. And then Datakin, that's your proprietary software to look at data reliability. Is that how the three map together, or what did I mess up there?
No, that's correct. So OpenLineage focuses on the lineage collection, right? So by itself, what you get out of OpenLineage is those JSON events that represent this job has run, and it was reading from those tables, writing to those tables. Here is the related metadata that, that was the schema at the time. At the time we write from the table, this was the schema at the time we wrote to that table, so you can keep track of when it changes. So OpenLineage is a collection of metadata, introspecting and getting this available. Marquez is an open source reference implementation that consumes those events, and it keeps track of everything that changes, right? So you can see how your SQL has changed over time. You can see how the schema of the table has changed over time, and how that's connected to lineage, right? Really having lineage at the run level, right? You see how change in the schema of that table was connected to change of the schema in this other table, for example. And then Datakin is another consumer of OpenLineage, and it's a software as a service, hosted in the cloud. It works a bit like Datadog. It's like you sign up for free, you get your instance, and then you configure your OpenLineage integration, and now you have this dashboard in the cloud that draws a map of everything you have, and then you can start looking at how it changes over time, right? Like how long it takes, is my SQL execution getting slower over time? Is the schema of a dataset changing? How do I correlate failure here with upstream changes, or invalid data with my upstream changes? So this is really, you can see Marquez as a reference implementation of OpenLineage that lets you look at the lineage and like explore the model. And Datakin is more of implementation of troubleshooting and impact analysis, really focusing on the operation use case. Is my data showing up? Is it showing up on time? Is it correct? How do I prevent breaking things? If something's broken, how do I quickly figure out the root cause of the problem?
Got it. That helps disambiguate them for me. super fascinating. I think we're big believers too in metadata and what you can learn from your data about your data. So I'm going to wrap up this episode with a question that we ask all our guests. Looking 10 years out, what do you hope to be true for the data industry?
From that, particular angle, I see a future where data is finally reliable, right? Data is correct by construction. And I think that's where dbt is an awesome product, right? It's kind of like the way you define your dbt project. It's really about building data correct by construction, right? It's kind of like dependencies are explicit. You understand your data dependency, right? It's not just run jobs after job after job. The reason you're running them one after the other is because there's a data dependency, right? And so as part of that, today, everything it's not just that it's always broken. If you don't know if it's correct or not, or it's really hard to be sure. And whenever something's broken or something suspicious, it takes a long time to figure out. So really, in the future, data is reliable, right? It's correct by construction, just the way you build things and you define your data quality or you define your job and your dependency, it's all by construction correct. When you want to make a change, it's automatically and immediately evaluated, and whether it's, you can apply it or not. I want to change this. Oh, no, it's going to impact that, right? And you can't break things unwittingly or unknowingly. And same thing, dependencies and semantics are explicit. You know exactly what the root cause of a problem is. Something doesn't run. You know that data is not going to be updated. It's really explicit, really easy to maintain, and people don't have to worry about all the plumbing anymore, right? It's just they can focus on what's important. And it's just, I have bad memories of being on calls for data pipelines. And it's just I want to live in a world where, on-call is not really, it's just something that, you get paged once a month and that's it, right? It's not everything's constantly broken.
Julia, what do you think? Do you think Julien is our biggest optimist yet? That's a very compelling world to live in.
Yeah, I was going to say, I'd like to get there too. So I think we're aligned definitely in that future.
Julien, it's been awesome to have you. Where can folks find out more if they want to learn?
Yeah, so if you want to learn, OpenLineage has a great website now, openlineage.io. There's a blog post where there's an interesting dbt blog post recently when we showcase how the OpenLineage dbt integration works. There's also, a great expectation example of how you use OpenLineage with great expectation. Of course, you can also go on datakin.com, and there's also a blog post that focuses more on the Datakin features, right, and how you use it. And so if you want to try OpenLineage with Datakin, you can go to Datakin, sign up for a free instance, do the trial. And if you have dbt, it's so easy to try out because you can just run dbt locally. You just configure, either you start a Marquez instance somewhere or you start a Datakin instance and you point your configuration to it. And then you run locally your dbt project, and then you start seeing it in that world. And what's interesting, if you have multiple projects, then it starts connecting them together, right? Or if you have dbt and Spark, then it starts connecting them together, and it keeps track of the evolution over time.
Amazing. It has been tremendously fun to explore 15 years of data history with you. So thanks again for joining.
Thank you for having me.
The Analytics Engineering Podcast is sponsored by dbt Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.